Again, I moved that recursion code into a separate package and subfolder and cleaned up my main.go file to dive into more function-related features. And now we're going to explore a concept called variadic functions, which sounds super fancy, but thankfully is extremely straightforward. Let's say you want to build a function SumUp, which should take a list of numbers and build the sum of that list. Now for this, of course, we could accept a slice of integers, for example, and then return a single integer. And in here, we can then build that sum by adding our sum helper variable, which is 0 initially, and by then using a loop where we loop through all the numbers in this list with that range keyword like that, and where we then simply set sum equal to sum plus val, or alternatively, we use that shortcut here, which is the same as setting this to sum plus val like this. And then in the end, we return sum. That's how we could write such a SumUp function. And now we can have our numbers here. So let's say that's such a slice of integers. And we can get our sum here in the main function by calling SumUp and passing numbers to SumUp. And we could also just accept the address, so a pointer to numbers, but that's not the focus here, so I'll just pass the value itself and hence receive a copy of the slice here in SumUp. But in the end, we get our sum here, and therefore, of course, as always, we can use the format package to output that sum. Now that was real quick, but there's nothing new in this code. If we would now run this, we should get 26, which is the sum of these numbers. Sometimes though, when writing code or when working on more complex programs, you might not have a slice or an array of numbers available. You might want to call SumUp, but instead of creating a slice in a separate step, you might prefer to just pass in your list of numbers like this, as simple parameter values. So that's now not an array, it's not a slice, it's just a list of free parameter values. But of course that doesn't work here because SumUp doesn't want free individual parameter values, instead it wants a slice of integers. Now of course you could turn that into a slice, but again having to do that here can be annoying and an unnecessary extra step if you don't have a slice from the start, so if numbers is not available as a slice, let's say. And that's where variadic functions come into play. You can write functions that work with any amount of parameters. In most cases, you clearly define that a function has 1 or 2 or 3 or whatever you need parameters. But sometimes you want to write a function that really works with any amount of parameters. For example, here I want to accept any amount of numbers as inputs, but I don't want to force others to pass in a slice or array of numbers that has to be created separately. And to handle that case, you can add your parameter here, let's say numbers, but instead of forcing this to be a slice, you can use 3 dots and then the value type of the parameters you want to handle, int for example. With that you're saying SumUp can be called with a list of separate parameter values, and you can have as many parameter values as you want as long as every single value is of type int. And of course, you could also accept different values like strings or custom struct types, but here I want an int. And therefore calling SumUp like this with 3 separate parameters is possible. And I could easily add a 4th one or a 5th one. That all works because the amount of parameters is now variable. It's dynamic. That is what makes up a variadic function. Now inside of that variadic function, so inside of a function that has this kind of parameter list with these 3 dots, numbers in the end, if we hover over it, will just be a slice of these value types. So the three dots in the end collect that list of standalone values and merge that all into a slice for you. That's what the three dots here in that parameter list, when defining a function, do for you. We still act on a slice of numbers, but now it's created behind the scenes based on a list of standalone values instead of forcing the caller of the function to create the slice ahead of time. That certainly wouldn't be the end of the world, but it's more convenient to do it like that. It's also worth pointing out that you can also mix this feature with other parameters which are defined standalone. For example, here, if we want a starting value, which should be an integer as well, we could accept it like this as well. And now the first value that we pass into SumUp would be interpreted as a starting value, which we then can use in any way we want in the SumUp function. And all the other values that don't have their own specific parameter defined would be collected together into this slice. So now these values here would go into this slice here. And this value here would go into the starting value. That's how this would now work. And you can write variadic functions like this as well in case you need a mixture of clearly defined parameters, which you might want to use in a different way, and then a collect all parameter, as we have it here, that then collects all the other parameters that don't have their own separate parameter, as we have it here for the first value.